Hey guys, welcome back to Chapter E. What we're going to talk about today is density. So one of the reasons that density is thrown into this part of the chapter is because it gives us an opportunity to practice both multiplication and division, as well as addition, subtraction, sig fig rules, kind of all in the same problem. So that's really the whole purpose of density being put into the chapter here. So density is the ratio of mass to its volume. So that's the English or the word version of it. Here's the math version. So density equals mass divided by volume. Mass is typically done in grams, so we put it on a scale, we figure out the grams. Volume, very often for us, will be in milliliters, so we measure in a graduated cylinder, and we get in milliliters. Another unit for volume is centimeters cubed. So that's one way we could get volumes to take length, width, and height, and that would give us centimeters cubed. If any of you guys have a medical background and you've heard of cc's, cc's stand for cubic centimeters. And as you well know, cc's and milliliters are the same thing. So milliliter, centimeters cubed, cc's, all the same thing. Density is an intensive property. So density is independent of the amount of a substance that we have. So let's look at lead, for example. So here's the densities of some different materials. And let's look at lead down here. So we have this teeny tiny little hunk of lead. And if I were to measure the density of that, I would see that the density would be 11.3 grams per milliliter. And even if I had a huge hunk of lead that was the size of a table, if I were to measure the density, so measure the mass, measure the volume, and divide those two numbers, I would still get a density of 11.3. So it's just one of those variables that it doesn't matter how much you have, the unit is always going to be the same for that particular substance. This is as opposed to an extensive property, which depends on the amount you have. So things like mass and volume depend on amount. So if I have a little teeny tiny hunk of lead, it's going to have a little teeny tiny mass. And if I have a hunk of lead that's the size of a table, well, that mass is going to be a lot bigger. So extensive property depends on how much you have. So what we're going to do here is just a quick plug and chug problem. So just get us used to using this density equation. So what is the density of a sample of liquid that has a volume of 22.5 mils and a mass of 27.2 grams? So one of my jobs as a chemistry instructor is to teach you how to organize your thoughts. It's silly on a problem like this that seems pretty simple and straightforward, but if you lay a good foundation of organizing your thoughts, it'll be very useful when we get to much more difficult math problems. So what I'm going to do over here is I'm just going to take inventory of what I know and what I need to find out. So I have density, I have mass, and I have volume. So reading back through the problem, what is the density? So density is what I'm solving for. I don't know what that is. It's a sample of liquid. It has a volume of, so I'm going to put that here for volume, 22.5. And a mass of, I'm going to put that here for mass, 27.2. Okay. So now I've taken inventory of what I know. I see that I only have one variable left. That's density. That's what I'm going to solve for. So now I just need to plug and chug. Plug this into my equation and chug away. So density equals, I put my mass on the top, so 27.2 grams. And I put my volume on the bottom, 22.5 milliliters. And I divide those two numbers. So when I type that into my calculator, 27.2 divided by 22.5, my silly calculator spits out a number like this. So on and so forth. But is that the answer I'm going to report? Absolutely not. What do I need to consider? I need to consider sig figs. So here we're multiplying and dividing, specifically dividing. So that means the weakest link. So I look at both of these numbers that I put into my equation. So both of the measurements that were taken, they both have 3 significant digits. So when I report my answer, I'm limited to just 3 significant digits. 1, 2, 3. So answers that I would accept would either be 1.20, and our units are grams per milliliter. Or if you notice that this digit is an 8 and you round up, I would also accept 1.21 grams per milliliter. So really what I'm looking for here is that it has 3 significant figures. That was a very easy, straightforward problem, but things are not always that easy. So the next example is going to guide you right into what you're going to be doing in lab. So here is how we would use it in lab. So let's say I want to know the density of this unknown metal, and I need to get the mass. Well, that's easy. I just take it and I go put it on a scale and it spits out the mass for me. But how am I going to get the volume? How am I going to get the volume of that unknown metal? So the way that we do this is through water displacement. So we take the metal, we look at how much water it displaces or moves, and that's the volume of that particular piece of metal. So over here, we've got 2 graduated cylinders. This first graduated cylinder has water in it. The water's just colored blue so you can see it, but it's just regular old water. So we put water into the graduated cylinder and we measure that at 35.5. Then we very carefully slip our metal piece into the graduated cylinder and we see that water level goes up, it rises. So the amount of water that it displaces, or the volume of that piece of metal, is the difference between these 2 numbers here. So we're going to look at how the volume changes. So the change in anything, so the symbol we use is this delta symbol here, so that denotes change. So the change in anything, in this case, the change in volume, is always going to be final minus initial. Okay. So the final volume is after we slipped our metal in, it went up. That's our final volume. So it's going to be 45.0 minus initial. So initial is going to be, well, how much water did we put in there initially or to start with? So that's going to be 35.5. Okay. Here we see this is an addition subtraction problem. So we have to consider sig figs. And what was the rule of thumb or the best way to do this? Well, the rule of thumb or the best way to do this is to stack them on top of each other. And then to draw a line after the weakest link. So in this case, they both have 1 decimal place. So that's where my number is going to be cut off. I'll keep everything to the left. So I plug those into my calculator. So 45.0 minus 35.5. And my calculator spits out 9.5. So that is the volume of this piece of metal. So let me go ahead and put milliliters here. That's the volume of this piece of metal. Now I need to take the volume in conjunction with the mass. And what I'm going to do here is I'm going to plug it into my density equation, and I'm going to determine the density. So remember, density equals mass over volume. So my mass is 9. Ooh, no, it's not. Just kidding. My mass is 68.60 grams. And my volume is 9.5 milliliters. So I plugged those into my calculator. So 68.60 divided by 9.5. And again, my silly calculator, I'm going to put it up here. My silly calculator spits out 7.221052, yada, yada, yada. But what do we need to consider here? Yeah, we need to consider sig figs. So down here, this was a multiplication division problem. So what's our sig fig rule for multiplication division? Weakest link. So in this case, our weakest link was the 9.5. So the 9.5, it had 2 significant digits. So when I report this answer, I'm limited to just the 2 significant digits. So to get all the points and to get this problem 100% right, you would report simply 7.2 grams per milliliter. So that ends our discussion on density. You're certainly going to get plenty of opportunity to practice this in the practice problems and also on your lab.